Hello, good morning. We'll start today's lecture in 10:30. Before we start today's lecture, do you have any questions for what we discussed up to last time? So if you look at my lecture note, this is my first lecture note, and we start from outline and tension and compression, the material law and shear. So for these individual subjects, you can find out separate the videos in my YouTube channels. Well, there's somebody's called me. Wait a second, please. 여보세요, 수업 중입니다. So today we're gonna talk about the bearing stress. So before we start this lecture, you guys are very welcome to have questions. Hello. Today let's talk about the concept of bearing stress. Last time we talked about the tensile stress here, the tensile stress, and then we talked about the compressive stress, isn't it right? So the tensile stress and compressive stress, they are what? So we'd like to consider kind of an average stress over the cross section. That was the tensile stress and compressive stress that discussed in this classroom. So today we want to talk about the bearing stress. The bearing stress in 우리말 we call 지압응력. 지압응력. This is called bearing stress. Okay, so let's consider a member. For example, a member is fastened by using a rivet or bolt, or you can consider a nail. Okay, so let's imagine that we apply a force to the bottom of the member. Then there must be three different failure mechanisms. The first one is what? So we can calculate because we have a hole here. We have a hole. And then this is net area, isn't it right? These are net areas. So if you calculate the average stress by using the net area, then force divided by the net area, then you can calculate the tensile stress, isn't it right? Tensile stress. So if this tensile stress exceeds, any, the strength criterion, then we can imagine that, this member would be failed by tension. So obviously, if you measure the tensile stress over this cross section, this area is greater than this net area. That's why the normal stress that we calculate for this cross section should be smaller than the tensile stress that we calculated, for this net section, isn't it? The second failure mechanism would be caused by shear stress. Look at this. Since we have, you have a support, then there must be shear stress development along this section, isn't it right? Along this section. Then how do you calculate the shear stress? For example, let's consider this length, for example, for educational purpose, and I'd like to say this length is equal to L, and then with thickness. Then the shear area, there's a shear area, then how many shear area do we have? So we have two of them, two of the reference area. Sorry, here the reference area can be calculated as what? So a node is equal to the length times the thickness of the member, isn't it? Okay. Then we can calculate the shear stress very easily. Shear stress is equal to force divided by the shear area. Shear area. And this is equal to F divided by 2 of the reference area. And then we calculate this reference area by using the length, to the free boundary from the bolt and the thickness of the member, isn't it? So again, this is similar to the failure criterion, similar to that of the failure criterion that we just discussed for the tensile failure. If the shear stress is greater than or equal to any criterion, typically we use F to represent any criterion. Okay, so if you put F tau, means that represents the shear strength that we have to consider in the design procedure. Okay. All right, then here it describes a certain condition where we have such kind of problem. It says that here the W means the D is the bolt diameter, and then E means the clear distance to the bolt, and W means width. W means width of the cross section. So here we have tensile failure. The width is small compared to the diameter of the bolt. Then we must have the tensile failure, isn't it right? We only have small ligament equals ligament. ligament means 우리말로 인대 뭐 그런 거죠. 인대 같은 거. 그러니까 뭐 인장으로 연결하는 거. ligament, small ligament. And then high, clear distance. But in the case of shear failure, the clear distance is very small. So which means the clear distance to the diameter of the bolt is very small. And then the width is big. In that case, we have shear failure. Then what's the bearing failure? The bearing failure is, so we have very good ligament and also very good the clear distance. In that case, here the material near to the bolt is crushed. This is bearing stress. Okay, so if you have a bolt and then there must be a hole like this. Oh, sorry. So let's consider we have a bolt and then I have a hole here. Then I have a hole. So let's imagine shape of deformation. So if you imagine shape of deformation, after deformation, the bolt is almost rigid, and then maybe, so we have strong contact here, isn't it? So contact, and then we must have a gap because of the consequence of the loading, isn't it? So that's why the material here under contact in such condition may be crushed. This is called bearing stress. Okay, bearing behavior. Then how do you calculate the bearing stress? The calculation of bearing stress is simple. The bearing stress, so we consider the force that we have to consider, isn't it right? The force. because please make sure that the unit of stress is force divided by the unit area. That's why in the numerator we need to consider the force magnitude, and the denominator we need to consider the area units, isn't it? So for this area, since we must have some thickness, isn't it, right? Thickness of this member. So we need to consider thickness, and then we simply consider the diameter of the bolt. Diameter of the bolt. Okay? That's how we calculate the bearing stress. Do you have any questions for the discussion of the bearing stress? It's easy, right? It's very easy. And then let's consider a specific example. Here I searched the internet and I found a paper where they did a test for the bearing behavior. And then here they consider two plates, and the two plates are connected by using a bolt. Because this bolt is connecting these two plates, and the width is large enough, and the clear distance is also large enough. Look at this. That's why we have bearing behavior. Actually, they designed this specimen intentionally to have the bearing behavior. Look at this. Here you can see the damage caused by the bearing. Here the material on top of the bolt is severely damaged. That causes bearing failure of the material. Well, let's consider an example for the calculation of bearing stress. This is example. Okay, so first we want to consider what? We want to calculate what whether. Okay, let's consider the gray part here, gray part. And then I want to calculate the tensile stress. So tensile stress should be calculated by using this net area here. Okay, then what is the force? The force is, so let's consider different color. So we have force is 25 kilonewton, and this is equal to 25,000 Newton. So as I told you, it is convenient to use the unit of Newton to express the unit of force. So if you combine it with the millimeter scales, you can obtain a megapascal unit automatically. And then let's try to calculate the area here, the net area here. So area is what for this gray part, and then I have what I need to subtract the rivet diameter. 25 minus the rivet diameter is probably 12.5, and the times the thickness is 7.5 millimeters. And then how many plates? We have 1 and 2. Two different plates. That's why we need to multiply 2. And the unit is millimeter square. So then here we can calculate the tensile stress very easily. The force divided by area. For the detailed calculation, try it by yourself. And then we can calculate the same. We can do the same thing for the blue part. Okay, so let's consider this blue part. So blue part, the force is equal to still same, isn't it, right? The 25,000 Newton. And then the area is what? The area is, the width is the still same here, 25 millimeters, because look at this here. The same width, 25 millimeters minus bolt hole, the rivet hole, what I mean. And then thickness is what? 12 millimeters. And then that's how here we can calculate the tensile stress. It's easy, right? So can you calculate the shear stress? The calculation of shear stress is also easy. Okay. let's try to calculate the shear stress. The shear stress. First we need to calculate the shear area. Shear area tau. So let's look at here. I have shear area, isn't it? So the shear area is clear distance to the free surface is what? The unit is not given. Okay, so let me skip it. So anyway, what we have to consider the clear distance and then thickness, and then also we need to count number of the areas for the calculation of shear resistance. Then it's very easy, right? And then the next step is let's try to calculate the bearing stress. So we can have bearing surfaces where the bearing surface is on the gray part. We have the bearing surface here, and then for the blue part we have bearing surfaces here. So we have to calculate that separately. Okay. Again, the bearing stress is equal to the force divided by the bearing area, isn't it right? The force is the same. This is equal to 25,000 newtons. Then the remaining step is we need to calculate the bearing area. So as I told you, the calculation of bearing area is the diameter of the rivet times the thickness, isn't it right? And then how many bearing surface, bearing part? We have 1 and 2. Okay, for the gray part, and the times 2. And this is equal to diameter is what 12.5 times the thickness is what 7.5 and times 2. Okay, that's how we can calculate the bearing stress. It's very easy. And then can you calculate the bearing stress for the blue part too? Yes, calculation is straightforward. Its calculation is also same. Stress is force divided by the bearing area. The force is 25,000. Then the area is what? The diameter 12.5, and then what? The thickness is what? Thickness is 12 millimeters. That's it. Okay. It's very easy. Do you have any questions for the discussion of this bearing stress? So if you don't have questions, let me stop the discussion for the bearing stress here, and then we'd like to move our attention to the next subject. The next subject is stress component by equilibrium. So we'll take the 5 minutes break, and then we'll be back to the class in 10:50. So I already generated a link to the next lecture. Okay, see you.